Well, good morning, everybody. Thank you so much for coming to my session today, and welcome to reInvent if this is your first session. If not, either way, thanks so much for being here today. My name's Todd Golding, as the slide says, and I'm a partner solutions architect at AWS, and I'm part of this team that is labeled the SaaS Factory team. And essentially that team, we're working with partners who are building and delivering solutions on AWS. And a big part of my interaction with those partners has included these sort of discussions where people come to me and say, okay, you're working with SaaS all day long, you're building SaaS solutions, you're talking to all these different partners. Tell me what the right sort of reference solution would be for me. Give me that cookie cutter blueprint thing that I can do, and I can pick up my solution and plug it into that, and I'll be all good to go. And while there's some merit to that, and certainly that's what it sounds like I think you're going to get out of this talk today, the real challenge of that is when you sit down and you really ask yourself, well, what is a SaaS reference architecture? Like, what does it one look like? Because I sit in the room with all these people all day, and it's a different discussion every time. And the challenge of that is, yes, there are reference architectures. There are monoliths, and there are containers, and there's serverless, and there's all these different things we can talk about as different ways to deliver SaaS solutions. But what it turns out is they're still largely building upon the core sort of reference architectures that you will learn about outside the universe of SaaS. So my challenge when I put this together was to say, okay, do I build these sort of one or two cookie cutter sort of SaaS reference architectures, or do I do what I normally do with SaaS partners, which is to say, here's the landscape of possibilities. Define a really good, solid landscape of what SaaS architecture looks like in the abstract, and then say, okay, now within each one of those boxes in that landscape, what are the different options and what are the different things you ought to be thinking about? And that's where you're going to make choices. Because what I find is the domain you're in, the security and compliance you're in, the legacy environment you might be coming from, the skill set of your team, there's just 100 variables that might point you at different flavors of SaaS architecture. In fact, when I think of SaaS reference architecture, I think of it as these building blocks that I'm sort of helping somebody piece together to say, here's the right variation of SaaS for you. So hopefully today, I won't disappoint you because I didn't give you one big end-to-end one, but I will have still given you a playbook, and I will have given you a set of patterns and a set of strategies that are the things you would naturally go back and think about. It is my checklist of things I do when I go through these solutions with partners, and this will, at least for you, say, these are the things I ought to be thinking about. These are the questions I ought to be asking myself. The other caveat I always have to give, because SaaS talks are always really hard for me, it's my third year doing these at reInvent, and one of the real challenges of a 300 level session is what's the right profile of somebody coming here right today. Today is not for a brand new newbie. I've never touched SaaS before. My expectation is you've got some exposure to fundamentals of SaaS. We're not going to start from ground zero. But it's also as a 300 session, we're not going to dig into code. We're not going to crack the IDE open, and we're not going to be slinging code and talking about how to actually build these things. I do that in another session here if you want to go to one of my deconstructing SaaS talk that I'm doing a couple repeats here. That's where we actually pull it apart and we get into the code. So if that doesn't fit and that description doesn't fit for you, I totally understand. If you want to try another session, it won't disappoint me. I just want to be sure we're all in alignment on what we're going to go through here today. So with that said, we do have to just lay a little bit of a foundation. So we'll have some sort of basic foundational sort of ideas here for what we should be thinking about and what language we use when we talk about SaaS architectures. Then we'll actually get into the architectures themselves. So one of the things we talk about all the time when we talk about SaaS environments is these different flavors of SaaS. And as you work with different environments and different partners, what you find are there's some pretty common patterns that are out there. And we use this language of silo, bridge, and pool to frequently classify how people are building their architecture or parts of their architecture. So when we talk about a siloed environment and we talk about silo as we walk through all these architectures, what we're really saying is in a silo model, some part of your architecture is separated for each of the tenants in your environment. They're not sharing that resource. It's distinct one copy of that resource for every single tenant. That resource could be compute, it could be storage, it could be the entire stack. Depends on the degree to which you want. Now, and on the other right-hand side there, the extreme is the pool model. In the pool model, this is the extreme opposite of silo, obviously. And the idea here is that the resources are being shared by tenants, right? So each of those resources, compute, storage, et cetera, are somehow being shared by tenants, and we have to deal with multi-tenancy through that lens. And then the middle one's just to accommodate the idea that there's always some variation in between, where you may have a mix of silo and pool together, and we refer to that as a bridge model. So this, as we talk about the architectures, I'm going to throw the word silo and pool and around a lot. Hopefully that will map back to this for you. The other thing I wanted to do is say, okay, if I were sitting down and building a brand new SaaS solution for myself, like what are the things I would most be on my mind? What are the challenges I would want most to be thinking about front and center for my architecture? Yes, I want scale, I want availability, I want all those things everybody wants in their architecture, but what are the SaaS things I'm thinking about, and what are the things that might influence the shape and structure of my architecture? And one of the things that is probably obvious, but not everybody addresses very successfully in their architecture, is this idea of variable tenant load. What we find is that in multi-tenant environments, getting new tenants all the time, we can't control that, so the profile of those tenants and the number of tenants is changing all the time, and their usage patterns are often unpredictable. They're using the system one way one day, and the next day they're using it another way. One day they're doing these really massive bulk operations at certain times of the day. How do I build an architecture that accounts for the fact that there's going to be this huge variability in this consumption profile, instead of a single tenant environment where it's 12 o'clock, we always spike right about here at 12 o'clock. In a multi-tenant environment, that graph might be changing all day long, every day, because of new tenants, new load profiles, and all those bits. So what do I do in my architecture to successfully build a solution that accounts for that? The other thing I want you to be thinking about, and I have whole talks just on this, is how is identity woven into your solution? And from ground zero, you have to be thinking about where is identity at? This isn't just about auth. This is about how do I connect users to tenants, and how do those tenants have roles, and how do those roles and all that context flow through all the services of my system, and how do I do that in a way that developers aren't having to have all kinds of awareness of that context? Right? So the truth is, to me, a really great SaaS system, a great SaaS architecture, would be one where the developers almost don't know they're building in a multi-tenant environment. I'm building a new service in my application. I don't want to stop and go, well, let's see, it's a multi-tenant this, and I'm going to have to get this from the security context, and whenever I go do this with the data, I've got to think about how the tenant context is applied there. No, I just want to go write code. And so we have to think about ways in our architecture that we can hide away this identity and flow it through this experience in a way that the team can still be as productive as they possibly can. The other item that is front and center for me is this idea of variable data footprint. And you could argue that this is a variation of variable tenant load, but for me it's not. It's entirely a different concept here, which is the idea that tenants and their data footprint, their usage of data, and how they consume data, how we protect them, their data from one another, all those bits are factors that you should be right in the front of your mind as you're thinking about picking an approach here. Instead, what I see teams do is they pick an architecture, they said, okay, what do we like to do? This seems like a good fit for RDS, we'll use RDS. And then 6 months down the road, their solution's alive, and they're finding that tenants are somehow saturating the experience of other tenants, and they're getting all these cross-tenant impacts, and they're resizing instances like mad to try to figure out how to scale, and they're regretting some of their choices there. The last one is one I just, excuse me, I have to include almost as on an obligatory basis because SaaS is often all about agility. So yes, we're going to do great things in the architecture, we're going to do great things to make it scale, and we're going to deal with the fundamentals of the architecture, but if I do all that and I don't have the ability to have this highly available solution that has zero downtime and gives me really good ability to repeatably deploy new versions and gives me the ability to roll features and functions really fast, I haven't achieved SaaS. So great, scale's awesome, but we can't only push out every quarter, and every time something happens in ops, everybody's hair's on fire, and we don't know how to figure out what's going on, and we can't predict when something's going wrong. That's not a very good SaaS architecture. So you have to include DevOps and metrics and analytics and operations in your view of a good architecture to me. We'll talk less about that here, but don't undervalue it. The last, well, actually there's two pieces here, but the other thing I want you to think about is multi-tenancy isn't a sort of black and white decision, and how you do multi-tenancy is we decided, and now this is our approach to multi-tenancy, and we're done. The truth is, multi-tenancy is a much more fine-grained decision than that. Yes, there's the simple case that you see here on the left, which is just, yes, and my web tier shared, and everybody's at that level pooled, and that's the way that we've built our web tier, and at the app tier, they're siloed, and we're done. Yeah, that's the simple version of it, but the truth is, if we look at modern sort of architecture and we look at microservices, what we're going to find with microservices is we are making multi-tenant decisions on a service-by-service basis. And in the example I have right here, and this is mostly centered around storage, I have a product microservice, I have an order microservice here. And I had to decide for product, I wanted to sit down and say, this product is representing multi-tenant identity this way, the flow of data and the way tenants consume data are this way, and what is the best representation of multi-tenant data for that service? Oh, I've decided here I'm going to put each separate instances for each tenant in this model, and I'll silo them that way. But in order, I've decided, no, I can use some pooled variation here, and I can put all the tenants in one table. In this case, and I've got some kind of index that is each tenant's ID, and that's the way I'm partitioning the data. So on a service-by-service basis, I can be deciding, am I silo, am I bridge, am I pool, what am I doing inside that service? And I want you to think that way because you often get a much richer experience, a better scale, a better overall sort of operational footprint if you're dialing in all the way down to the service level here. The last piece of this is, doesn't matter, bridge, silo, pool, whatever you're doing, there's some things I would ask you, no matter which architecture you build, are you doing well? Do you have frictionless onboarding? How does a new tenant get created and put into your environment? I'm going to ask you that in any architectural model. And yes, you could say, well, our B2C, they sign up on a registration page, or we're enterprise, and somebody signs a contract, and somebody internally creates that tenant. Both of those should be frictionless experiences, if it's an end user or an internal person. So I'm going to ask you, how much automation have you got around that? How repeatable is that process? I want to see whether you're doing zero downtime deployments. I want to know whether or not you've got some way that you're rolling features and functions in a way that customers aren't having outages and parts of that, because that sort of undermines your agility. So what have you done for that? These next two kind of go together, but I'm going to ask you, what are you doing about monitoring and management? How can you really tell me the health of a tenant at any moment in time? How can you tell me if some part of the system is unhealthy for a tenant before it's actually visible to that tenant themselves? Because our whole goal here would be, we want to detect these things, react to them, and respond to them before the tenants ever see them. Because if we have an issue here and somehow the system goes down, it goes down potentially for all of my customers. It's a huge issue. And then the last one's not very exciting there, but we do have to think about centralized billing. A lot of people put billing off as this sort of afterthought of their architecture, but you really ought to be thinking about, how am I going to measure consumption, and how am I going to bill for that consumption? How am I going to integrate with that, and how is that going to affect the overall life cycle of how tenants are managed as customers in my system? That one almost always gets put off. It's not a huge penalty to put it off, but then it eliminates the business's ability to think about, how would we potentially create tiers for these customers? How would we bill for them? What are creative ways we can think about how to package our product and offer it? Okay, and I promise that's the fluff and the setup to sort of give to you the mindset here that shapes it. Well, let's actually talk about the architectural landscape. And I said I'd sort of build this broader diagram here, right? And what are the building blocks of that? Well, onboarding has to be part of this. Onboarding isn't just a concept. Onboarding is an actual set of code and services that have to be part of orchestrating what it takes to get everything set up, to get this tenant created in your system. We're also going to look at access, like how do people get in, how do they auth, and what does that look like? It's back to that identity story. And we'll look to a lesser degree. I don't even know if, actually, I don't think we'll touch on this one a lot. But API access is also this. If you're going to have developer APIs here, how are you going to expose a developer API? What are you going to do for tenants here who may be from different tiers to throttle their experience via that API? How are you going to manage keys, things of that nature? Then below that is this notion of application services. This is the sort of heart of the application and the part most people want to talk about, which is what are the business services of my application actually look like? How do I host them? And what does it look like if they're in serverless versus containers and all those other good things? So we'll poke at that. Storage partitioning, probably the one almost everybody thinks about. In fact, a lot of people think multi-tenancy is just data separation. It's certainly way more than that. But we'll look at storage partitioning, and we'll look at how we isolate tenant data and how we separate tenant data. And then this notion of tenant isolation. How do we make sure one tenant can't see the resources of another tenant? Okay. Then we'll look at some of the sort of surrounding bits of this to a lesser degree. We'll look at metrics and metering, and we'll look at billing. We won't really get into management monitoring a ton in here, and we won't get into DevOps a lot here. But if I felt like, even though I wasn't covering them very deeply in this session, if I was going to make a complete sort of blueprintish, reference architecturist, conceptual architecture, that would be it for me. So hopefully all these things are the things you're thinking about. And now what I want to do is say, well, let's start by focusing in that middle box. That middle box, set of boxes there, is really where most people are thinking about their applications. This is where you're building the core functionality of your application. How are you writing the services? How are you representing customer data? And so on. So let's start by drilling into those boxes. And this is back to kind of what I said at the top a little bit, which is when I sat down to try to build these reference architectures, what I found was most of these architectures were extensions of existing models. But I still have to call them out, I think, as SaaS architectures. So there is the SaaS monolith. It is the monolith that we've all known to sort of know and love, or know and hate, depending on your experience. But this idea that we would have a multi-AZ environment, we'd have a traditional sort of N-tier architecture, some web tier, some app tier, and some way to represent tenant storage, might be separate databases. I'll actually often see here one shared database that all the middle tier is working against. And it has all the sort of downsides that you would traditionally see in a monolith environment, right? We tend to deploy the services here as these big chunky services. So if you look at the app services, there's, yes, conceptually inside some big jar or some assembly from .NET, there's a bunch of business services, but they're all being deployed as one big unit to an app tier here. And if something goes down inside of one of those services, the entire app tier tends to go down. We end up with really tight coupling between these concepts. We end up with coupling often to the data model, where if I want to deploy a change to the data model and it's only for some portion of the app service, it doesn't really matter. All of these things tend to get deployed in one really big bang. So really and in SaaS environments, this is often an environment we'll see where people have come from a legacy environment. They've said, we were already a sort of a N-tier solution already, so we sort of put multi-tenancy awareness, we injected tenant context into this, but we mostly kept these sort of coarse-grained services, and they start with that as their starting point. Obviously, there's just, if you've worked with monolith at all, the list of reasons why monolith is not a good idea are pretty well understood, and this is why we've been sort of pushed towards containers and microservices and other kinds of models of decomposition. I will say one of the evolutions of this I have seen is that people will swap out EC2 here, and they will run these services in containers, and you'll start to see these monoliths broken apart a little more, where people will run some of these services in separate containers, but still has most of the values of a monolith. Of course, just like traditional cloud native apps evolved, so did SaaS apps evolve here. And so what the other flavor we'll see here is microservices-based architecture, right? Where people will say, now we're into decomposing our SaaS application and these application services into smaller bits. And they'll end up basically deploying. Now you'll also see on the more modern apps, people pushing the web app all the way to S3 buckets. And this is where you'll see in Angular and React and all those other tools, pushing all the web client over to S3. and all being run inside the browser. And then we have a NAT gateway and some microservices. I'm running through these because I feel like these are ones that are sort of the vanilla sort of flavors you've seen before. It's more about what's the SaaS variation here, and some load balancing across them. And the biggest difference in this microservices-based SaaS model is that essentially what we've done here is we've said we're going to decompose the system more. We're going to break the system down into these smaller services. They're going to spin up. They're going to have a better fault tolerance footprint for our SaaS environment. So as these services, if one of them goes out or down, it won't take the entire system down. And it really will inherit all the values that we will see generally of a microservices architecture here. The key is how successfully do you decompose these, how big are these containers. Some people will go to this model, but they'll have still these massive coarse-grained kind of services. Didn't really achieve that much different in the monoliths. So if you're going to go this way in SaaS and you're really going to have a great availability and a great scale profile, you're really going to want these to be finer-grained services. And now we get into this model where we can start matching tenant consumption to the actual footprint of our infrastructure, right? Because now we can dial these containers in so that they scale as individual services based on the actual activity of our tenants. So we have storage here that's typically in this model, each service has its own sort of encapsulation of storage, where each microservice has its data on its other side of the wall. So now we've moved away from any kind of shared data across services. And this is absolutely a really great way to build a SaaS solution. Smaller deployments, it has better agility overall. You get a much more distributed data model, so now you can start making those layer by layer decisions about multi-tenancy and how you want to partition data on a service by service basis. So a really good evolution. And then the last flavor of this is serverless SaaS. I have a whole session I'm doing on serverless SaaS. Probably one of the most heavily used areas for serverless is SaaS environments, just because it's such a great alignment between sort of the needs of consumption and matching consumption to infrastructure footprint. But if you look at a serverless SaaS architecture, it doesn't look all that different than a traditional SaaS. Somewhere here, somebody's presenting something on serverless right now, and their diagram probably looks pretty much like that. We're going to have a web client, again, pushed out to S3. We're going to have the gateway. We're going to implement our services now as functions, so much more fine-grained than we had with the container potentially. And then we're going to have storage services. And we'll talk a little more about what those functions look like. One of the things you do see here is you'll see the notion of the API gateway may or may not have been in your world before. And so now with Lambda, the API gateway will definitely be in your world. And so now we'll see like authorization, and we'll see other mechanisms introduced at the API gateway to better secure your environment and control the access. But really, what we see here is this fine-grained approach is really just another incremental evolution of what we see with containers, right? Now, by being even more fine-grained, we get even better deployment and model. We get even better fault tolerance kind of models. But the best one here for me is this has the best story to tell in terms of actual cost optimization. I said at the beginning, one of the things I'm always thinking about is how do I match all this crazy tenant activity with actual compute sort of infrastructure that is the right footprint of compute infrastructure. How do I not have to over provision? Well, now when I'm in serverless and I'm running managed functions and I'm not running servers anymore, and the scale of those managed functions is AWS's responsibility, now it's just whatever my tenants run. If you're not running any functions, I'm not paying for any functions. If I'm in the other footprints, if I'm in EC2, if I'm in ECS, I'm going to have some idle footprint no matter what's going on for every service in my system. Here, it's truly based on consumption, and the best news here, I'm not the person who has to figure out what's the right scaling policy, right? When I'm in ECS, I'm in EC2, scaling policies are still my job. In serverless SaaS, that's Lambda's job to figure that out for you. So again, more focus and more attention on your code and your business problem, and less focus on how these bits get out. Now, those three, and I rushed through them intentionally. The reason I rushed through them is because I don't think they probably are all that new to anybody who's been poking at cloud native design. You're probably thinking about containers already, or thinking about whether it's serverless. And on their own, SaaS doesn't fundamentally change the architecture. They mostly change what happens as you implement the individual pieces of this. So I want to put more of my focus on that aspect of it. But I do want to give you a clear sort of view of what I think are some of the trade-offs here, just because I feel like this is a good summary of it. And I think a lot of this is probably already obvious. But if you sort of work it left to right, monolith to microservices to serverless, you'll see that generally most things in the monolith don't do so well for SaaS. But the one area it tends to do well is developer experience. People still love the fact that they've got this ginormous jar and they don't have to worry about crossing any boundaries, and they can change whatever they want to change. And so you have to admit, for some people, that's a better developer experience. So as you move across, I actually feel like developer experience might get a little more challenging for some folks who are building functions, for example. But you'll see then, like deployment, fault tolerance, microservices are a good evolution of that. And then to me, serverless is the sort of ultimate extension of that. And cost optimization, the last line, may be one of the best ones to look at, is this idea that serverless really gives me a much better way to manage consumption. So what's more interesting to me as a SaaS architect, though, is what's running on those services. If I'm running on ECS, or rather I'm running on serverless, what do I actually see in those functions that are inside there? That's where it gets interesting to me. That's where SaaS adds architectural considerations, right? Because now if I have this service has to say, hey, somehow tenant context has to come to me, and I have to apply that tenant context. I have to get authorized as they come in to me in a tenant context, and as I want to log data or meter data, or I want to go get data from storage, all of that needs to know who you are, what tenant you're connected to, what role you're at. So how do I do that in a way that means that the developer of that service, who's just working on the functionality, doesn't have to think about how to apply those concepts? And almost every presentation I have has some slide that looks like this. My serverless slide has the same point, because to me, this is one of the most fundamental areas that people don't focus on. Instead, they sort of let a lot of the logic get embedded in the services and a lot of the multi-tenant awareness embedded into the services themselves. So I just want general good design sort of principles to be applied here and say, okay, introduce frameworks, libraries, tooling, whatever it is you're going to do to say, when I want to log something in a service, just log it, pass the context along with me, and let the logging system figure out which tenant I'm logging on behalf of and whatever tenant context needs to be here. If I want to go access some storage and there's some partitioning scheme that describes where that tenant's data resides, I want something else figuring out how to get the connection string for me, or how to figure out which key mapping there is to go get that tenant's data. So all of this to me is about what you're doing at those layers. And to me, you can't, this would be the same across any implementation of monolith, microservice, or serverless strategy. So the other bit of this is, okay, how do I actually carry that through? What would that actually look like? The example we do in identity all the time, one of the examples we advocate is the use of JOT tokens with OpenID Connect. It's one of many ways, but it's a very common way people are addressing this. It's the most common way I'm seeing. In fact, I tried to figure out if there are a lot of other patterns here. Yeah, people are passing other tokens, and we'll get into auth patterns a little bit here. But generally, some tokens coming through, and hopefully that token's coming through with SaaS context in it, so your tenant ID and so on. That'll hit your app service, and then your app service will go to some data access layer or some sort of helper library and say, I need products. Go get products for me from the database. I don't know what tenant, I don't know anything about multi-tenancy, just go get me products. That data access layer will say, hey, token manager, go get me the tenant ID out of this incoming request, and then go to the partition manager to figure out where the data actually resides for this particular tenant, and then go find that data for that tenant. And so nothing magic or nothing special here, but you should notice this is a realization of the values I had on the prior slide, which is the person who wrote that app service didn't have to know anything. And if I would have put logging on here, it would have been the same thing. Metrics, same thing. Everything we do that requires tenant context should apply that policy more universally outside the scope of the actual service itself. Now, storage partitioning, got a whole white paper on this. We're not going to drill wildly into this, but it is a big part of building the app building blocks. I said we were staying in that square. What are the sort of core concepts here? Well, one of them is silo relational. Obviously, you can store separate instances or have separate tables, separate schemas for each individual tenant, and that's one way you can represent individual data and then have to do some kind of mapping. The obvious other variation of this is Silo NoSQL. Well, now Silo NoSQL has another set of considerations. If I'm using DynamoDB and I'm doing a silo model, well, table space is global to an entire region. I got to have a naming scheme for my tenants that will put each tenant into their own table. Then we have the pool model. Now remember, pool is where we're sharing a resource. So here in this case, we're saying, hey, we have some table. All the tenants are going to go into this shared construct, which is this table. And in this case, it could be relational, it could be NoSQL, so it could be an RDS table where the foreign key is a tenant ID, or it could be DynamoDB, where the item in the partition key is some tenant ID. No magic to this at all. And definitely go, if you want to go check out the white paper, lots more detail on this. I did want to include one more here that was sort of maybe an outlier a little bit, which is what about object storage? So far I've talked about things that are sort of relational and NoSQL tables. Those models are pretty clear. What do we do with something like S3? Well, in this model, we're actually going to use tagging as a way to do this. So we really want to just say, put all the objects into the database, tag them as belonging to a certain tenant, and go ahead and get them. And that's our way of partitioning the data. Another mechanism, I didn't include it here, but another mechanism I've seen people use here is they will actually create a relational table that's a mapping to the object. So they'll say foreign key is the tenant ID, and the value it's mapped to, the object value key it's mapped to, is another column in that table, and they'll use the relational table to go look up data for a tenant. Also a perfectly valid strategy. Usually people want to talk about this one a lot, but the reality is there's a handful of ways to do this. It gets a little more interesting. Maybe you get to Redshift or something like that, because now are you building a cluster per tenant, or what are you going to do? But in general, you're still generally going to choose between, is it going to be separated and at a silo boundary where tenants are truly separate from one another, or is it going to be pooled? And there are trade-offs to pool and silo both. So here's the other part of this, though, that is a part nobody thinks about. And this is where I said partitioning at every layer matters. All right? And the thing I really want you to think about is, okay, I chose silo, I chose pool, whatever I chose. Typically, there's some kind of compute construct that's between me and the data, especially if I'm using a relational model. In fact, there's an RDS instance. That instance has a size. It has performance, right? So, well, now if I'm going to throw that into a multi-tenant environment, how can I ensure that that instance is big enough? Like, if the load on that is constantly changing, and the nature and the profile of how tenants are consuming my data is changing, what do I do with that? What's my multi-tenant strategy that evolves to get me to that? A DynamoDB is another variant of that problem. What if I saturate the partition key of some table? What if one tenant consumes 90% of the partition key values for my SaaS solution? What do I do with that? So my point here is that you have to think about how your multi-tenant model at the storage level is going to scale. That's almost a more challenging problem than silo or pool. So what are some of the ways we scale this? Well, one I really hate but have to mention because it's valid is this idea of doing kind of what we'd call a shard of shards. We have to say we're going to horizontally scale the storage. Okay, so that means we're going to add, if it's RDS, we're going to add many instances, and then we're going to need some way to say which tenants are in which instances. And I'm going to need some kind of mapping scheme that says as I consume them, I'm going to go through that level of indirection to figure out where that tenant resides. So when my partition manager I had in the earlier example resolves that, it's going to go through some table and figure that out. Or it's going to do the same thing. It might do the same thing with tables in DynamoDB. I might distribute this across many tables, and I'll say these tenants are here. makes the access patterns more complicated, makes aggregation more complicated, but it does address scale. My fantasy world is that, that serverless will find its way all the way to storage, and it's starting to do that. So if any of you have looked at Aurora Serverless from AWS, it targets this very specific problem to me. I don't know if they were thinking about SaaS or not, but for me, it was like right in the sweet spot of what I wanted as a SaaS developer. Because with Aurora Serverless, what we do is we get to take that same serverless mindset of Lambda and apply it to our RDS instances. So now, there's a proxy fleet put between my application and the actual Aurora instances. And what Aurora will do for me is it will say, I'll take care of deciding what size instance you need. You just consume the data, and I'll keep a warm pool of instances over here of various sizes. If you're not using anything, there'll be almost nothing there, or really small instances, and you're still only going to pay based on whether you're actually accessing the data. You'll still pay for the storage the same way you did before. But if suddenly there's huge ramp up in activity, it'll bring in from this warm pool these instances that are the appropriately sized instances. So now we're no longer chasing this whole problem of what size instance should we have here. Of course, that solves the problem for relational. We need equivalent answers to lots of other storage technologies that get us away from this. In general, just if you have an instance or you have something that has a performance metric on it between you and your storage, ask yourself, if tenants come in these crazy patterns, how will it scale for me? The last piece of that box of application services that we have to talk about is isolation. What do we do with isolation? And isolation is often one of these stories that when I bring it up, everybody's like, yeah, you need tenant isolation. And then I'll ask them, what are they doing for tenant isolation? Well, we auth. Auth is not enough. If you're really thinking about good isolation and your whole business counts on the fact that one tenant never gets to another tenant's resources, or you may be out of business, then you have to have an isolation strategy that's broader than auth. You have to say once something, at every layer of my architecture, when somebody's touching a resource, what am I doing to make sure they're touching that they're valid to access that resource? So here I want some notion of policies or role-based access or whatever it is. It can be your own homegrown thing, but I want something constantly saying, I'm applying some kind of security context, some kind of isolation context each time you cross a boundary to say, can you access that resource? And I'll say now, this is not easy. Some resources are really make this easy. Some, it's really challenging to get this right. But don't punt on it just because it's hard. You may have to write some of your own code here to make some of this work, but you have to go after this problem. So what are siloed compute isolation kind of look like? What are some of the common patterns? Well, we see VPCs. So if you're an EC2-ish kind of world, or not even VPC, you could do this in any kind of VPC. You could use networking constructs to basically say, people get really comfortable with this idea of, hey, I can put security groups and I can put these other things around my tenant resources. And if they're in a silo, I'm all good with that. That makes me comfortable and I can tell my customer that somebody shouldn't be able to cross a tenant boundary. The other thing we'll see is in ECS, we'll see namespaces sometimes used. So we'll use a namespace and associate a set of containers in that cluster to belong to a given tenant so that they can't cross boundaries that way. And then the other one is Lambda, and Lambda is the trickier beast of these. One way you can solve this, but I get into this in much more detail, is to say, hey, I'm going to apply IAM role to each function. That IAM role for that function will control the access I have to resources. And this is all about compute isolation, you'll notice. I haven't talked about storage at all, but these are all different ways that I can say, could somebody on this instance somehow cross a boundary to another instance? Now, one interesting caveat on Lambda here is if you're really executing a Lambda function, you're always executing in the context of a tenant at a moment in time. So there's interesting questions about what that means to isolation. Could you say, well, if only that one tenant's in there executing, aren't they already isolated? There's some things that can go on there. We talk about a little of that more in my serverless talk, but it's a different dimension than, say, ECS or containers, where you might say, here's a service, and in a pooled model, multiple tenants are consuming that service. Well, now what's your isolation story? Because they're all sharing that compute construct. little more difficult, easier to talk about in the siloed model that I described here. So pooled compute isolation. My story around this one is really just what I would call sort of runtime acquired context. So if I log in and I get an identity and I have some identity and I says, here's my role, here's the things I can access, here's who I am as a tenant. Now I'm going to go into this pooled compute area where my services are running there and all the tenants are running in these shared pooled resources. And now what I'm going to do is say, anytime one of these compute resources want to access data or access some resource, doesn't have to be data, I'm going to get scoped credentials, and I'm going to get something that says, here's the scope of what you're allowed to do. Now go engage that construct. And if you, and when you do, those scope credentials ought to be able to verify, are you allowed to touch that, that resource or not? So we're essentially runtime acquiring a set of credentials and then accessing resources with those credentials. Now, data isolation is a slightly different story. Now we really are down to, and I'm talking about IAM here because IAM is the thing that AWS has as a common tool to solve this, but this doesn't have to be IAM. People do have their own sort of RBAC-ish kind of bits here that you could consider using as well. But here I could say for each, in a siloed sort of world where I have a tenant for each database, I could set up an IAM role and say, hey, I'm going to assign that IAM role, and now when I go get the creds, either like my Lambda function has that role, or I dynamically got credentials at runtime for that role. Now when I go to access that instance, I'll be in that context of that tenant. So if I try to go get another tenant's data, I won't be able to. The other model we'll see here is one where we have key-based isolation. So here in a pooled model where all the data lives side by side, I will be able to define roles to say, you can only see rows with this particular tenant ID or items with this particular tenant ID. And so now if somebody tries to cross a boundary within that table, they'll be prevented from doing that. And here's a really simple example. I picked one that is straight out of another talk I'm doing this week. But here at the bottom, this is an IAM role. And pay attention to the very bottom of the screen here. You'll see I have a condition defined down there, and I have a leading key defined. And that leading key presumably is a tenant ID. So now when I log in and I have my identity and I marry it to this policy and I go to access a table, that policy will say, I'm only going to let you see items in that DynamoDB table that have that tenant ID in it. This is an awesome example of when it works. The problem is each storage technology has its own approach to what policies and with what granularity you can define access. So Dynamo gives me this really fine-grained control that's awesome for what I want to do, but other storage technologies have their own nuances to this. My big takeaway here is IAM, no IAM, I don't care. I want you thinking about how would I do something like this in my own application? When somebody goes to get data in my application, what am I doing to challenge their access to that data? Because I have really strange conversations where people will say, but they're inside, they're a service, there are developers, like they're trusted at this point. No, your team can still make mistakes. You can cross a tenant boundary without intending to cross a tenant boundary. And so I want to protect the app, and I want to protect that developer every way I can. The last one's the obvious one, what I just call full stack isolation. That means every resource is separate for every tenant. Still valid SaaS, by the way, because we'll still have onboarding, frictionless onboarding. We'll still have all those values we talked about. It's just every tenant's going to have their own stack. Not so great on the cost side of the universe, though. Okay, so that's the middle box. We talked about app services, isolation, data storage. Now let's hit on a few of these boxes. We won't be able to hit them all, but let's hit on a few from the outer edge. So identity onboarding, right? This is an area that I think you all have to think about. And when I think about onboarding patterns, I think about, okay, what are the ways, the building blocks that I would do in any solution? Well, there's going to be some onboarding page, and that onboarding page could be an internal page. It could be, again, this could be B2C, where it's a sign-up page out in the universe. It could be an internal page for just somebody in your team provisioning a system. I still want there to be some automation to that. And then really it's, the other building blocks are, I need some notion of user identity. I got to have some way to introduce users in the system, and I got to be able to map those users to tenants. Then I also have to have some notion of provisioning, especially if I have siloed environments. How does my onboarding create and provision the constructs that are needed as part of my experience? And finally, I have to actually create a billing sort of footprint as part of onboarding. I've got to charge them, presumably. How do I create a footprint for them that is their billing footprint in my system? Well, there's a couple approaches to this. My first one's the simple one, which is zero touch, like volume onboarding, typical B2C-ish kind of model. Here I've got a series of services. So in this example, this is straight out of another example we've built. I hit a tenant registration service. That service hits some user management service. That user management service uses OpenID Connect to manage my users and provisions my users. It goes and provisions whatever policies need to be provisioned that are going to use to scope my access to data. Then in this case, I'm using Cognito, so it's going to map. I'm going to use user pools for every tenant. Not a super important concept to take away from here, but if you're using Cognito, a good way to do this. And now my user and all their policies are created. Now I actually have to create a tenant. Somewhere out there, tenant has to reside separate from the actual user in the system. So create the tenant, what is their ID, what is their tier, all those other bits. And then finally I have to go do that billing footprint part of this. Here I've just wanted to convey the idea that billing should be as async as you possibly can, could be an external third-party system. And so when I do this, I want to say, go ahead, sure, onboarding, go create that billing footprint, and you can retry if it doesn't work, but I'm not going to have my onboarding fail based on the account getting created or not get created. But these are all the moving parts in this volume sort of model. Now, if we move from the volume model to what I would call enterprise SaaS model, and this is one where somebody goes through some protracted process of acquiring and signing a contract. They make a commitment, they sign a 2-year potential deal or with your organization, and then finally that contract gets handed into the internal engineer, and the engineer will go run some provisioning process to say, go create that tenant. I want that engineer's experience to be this seamless, simple, repeatable process that says, I've created and kicked off some provisioning process. It's still going to go create the billing, the identity, and all these other bits. One of the other bits that's going to potentially happen here if you're in a silo model is I'm going to go actually create AWS constructs. So you can imagine if I'm full stack isolation, I may have to create VPCs, I may have to spin up instances to provision you as a tenant as part of this onboarding experience. And at the bottom, I just showed some limits, service limits that may need to be adjusted. You may need more auto-scaling groups, or you may need more DynamoDB read capacity based on the creation of this new tenant. So these are all sort of the two extremes, sort of B2C sort of world, and one that's a much longer heavyweight process, but a shared value system. Now, authentication. There's a couple of flavors for how we see people auth in this world. So we look about getting auth into the environment. And the first one I'm talking about is one that I wish didn't exist, but is really common, which is this idea of delayed tenant resolution. So in the authentication with delayed tenant resolution, I'm going to hit my web app. My web app's going to go to my identity provider, and my identity provider is going to provide back whatever the auth token is to say I want to get in here. I'll go back to my app. My app will hit my service, and my service will say, hey, I need to go get some data. Yeah, who's the tenant? Well, I don't know right now because all I know is you authed as a user, but I have no idea which tenant you're working on behalf of. No problem. I'll go resolve your user to a tenant through some separate service. That service will tell me what tenant you're part of. I'll hand that back, might even hand back some RBAC policies, and then I'll finally go get the data. Built the system, did this wrong. The challenge of this one is that this delayed resolution ends up becoming a big bottleneck of your system. Becomes a performance bottleneck, a scale bottleneck, and suddenly you're chasing scale there instead of in your actual application. So the other variation of this is authentication with a true SaaS identity token. I talk about saying, when I say a SaaS identity token, is saying, hey, I get an identity token that has all my SaaS context embedded in it. So that all happens at the front of the process. So now I hit the web app pips OpenID Connect, and now it hands me back this wonderful token that is enriched with tenant ID, role, tier, any kind of context I need. And now, when I go back and I hit my actual service, yes, the only thing I need before you showed I got RBAC, I'm going to go ahead and get these IAM constructs. So I'm going to go get these security credentials to make sure that these have the IAM policies attached to them. I'm going to get that token back, and then I'm going to use that token to get the data. But I did nothing in this to figure out what tenant ID, just to say which tenant ID are you, which role are you. It all came to me embedded in the token. Now, the third one is just a reality of any environment, which is sometimes you don't get to control where the identity provider is. Sometimes your customer has an Active Directory or it has some kind of directory, and they're going to say, you have to do SSO via my directory. There's no way around that. So here you have login, you have some kind of authentication manager, and that authentication manager has some kind of configuration that says, where is the directory that I need to auth you against? And in a lot of these cases, I've introduced this, I debated whether to introduce this. Sometimes people will have a mix. They'll say, I have my own internal one, or I allowed you to use your own directory. So if it's internal in the config, I'll go to my own Cognito provider, and I'll auth you that way. Oh, but no, you're an external one. I'll go to the external identity provider, and then I'll flow that through, and typically now have to do some kind of mapping of that user to a tenant, because guess what? The external provider has no notion of tenants or anything else. It just knows users. So it's another variation of delayed sort of mapping here. So you'll see I resolved it, I authed you against it, and then there's a secondary step where some internal process says, now that I know who you are, I have to I'm the one who owns what your tenant mapping is, so my internal services will create that tenant mapping for you, and then I'll use that to eventually go access the service. Really common pattern. I think the fact that when you don't control the identity provider, your identity story in SaaS just gets harder. There's no way around it. The last bit here of auth is that I definitely want you to think about the fact that a user could belong to multiple tenants and what you're going to do with that. And also I want you to think about how can I push policies to the tenant level themselves? Like, am I going to require MFA? What are my password policies? Don't make that a global policy for your system. Make that a tenant by tenant kind of policy if you can. The last bit of this is multi-region auth, because a lot of people are building multi-region solutions. And they're asking me, like, what do I do for auth here? Well, there's two approaches to this. One is I have some centralized shared onboarding experience, some shared auth experience where somebody comes and logs into my system and they use some shared identity repository. So all my users are in some shared centralized location. That auths me, and then I go access the services that I want to access. The problem is if you look at GDPR and look at generally what people are saying about where identity ought to reside relative to a region, a lot of businesses aren't comfortable living in a shared identity provider with other tenants. So this can work, but what I see more often is this sort of notion of region selection where, yes, I land at some common entry point, but then I choose from there which I provide enough information to route me to the appropriate region, and now the identity providers move to the actual regions themselves. So I delay the auth, I redirect to the region, and I let the rest of the auth process happen inside the region itself. Metering and analytics. There's not a lot here, believe it or not. Metering and analytics isn't a wild, crazy SaaS pattern. It's more just go do it kind of thing. And it's more about what are you actually metering, what's in those messages. So here we say, yes, we've got some API gateway hitting some app service, and then I want some metering framework. This is all the way back to surrounding services with helpers that hide all these detail away. I want an app developer to just say, publish this metric, and then it's really all about what are you putting in that metric. Every one of those metric events ought to have tenant context in it, but then it should tell me about consumption, it should tell me about usage activity. I want a generic way to say I'm capturing all these metric events that can be consumed and aggregated, that can give me the pulse of what's going on with both my users and their activity, but also the performance, the scale, the behavior of my architecture. And then it's just about aggregating it somehow. And I aggregated it with Kinesis and Firehose and with Redshift, and then surfaced it all with QuickSight. That could have been Elasticsearch and Kibana. It could have been any number of things there at the bottom. I happen to pick a set of tools. The key thing is all this data goes to a central location, and then it gets surfaced to whoever wants to consume it. This data often seems like, oh, we're publishing it for a consumer. No, don't think of it that way. The pattern I want you to take away from this is we're publishing it for any consumer, and I want these other consumers to start deciding where's the value in that data for them, and I want to create this cycle where they're coming back to you and saying, I want more data out of this. Publish this metric for me. And these metrics are the lifeblood of SaaS organizations. SaaS is a metrics-driven universe. And if you don't have this kind of plumbing somewhere in your solution, you're not going to be able to make good decisions about how to evolve your system or evolve your architecture. The last one here is pretty straightforward. We talked about billing and account management. Yes, this metering, somewhere out there, metering will happen, and metering will aggregate all of your consumption data, and then eventually it's going to have some integration with an actual billing system, either your own internal billing system or a third-party billing system, and it's going to send those appropriate billable units into that billing system, and that billing system will be responsible for generating a bill. I advocate third-party billing systems here just because I think owning this effort to build all of this and manage all these policies and manage this whole life cycle shouldn't be your responsibility. It takes your focus off of your system itself. And then the bottom piece of this is the piece everybody misses. Yes, we have a way we can generate a bill and we can send the customer a bill, but we also have a relationship with that customer on an ongoing basis, which is they're deactivated, they're no longer running. How does that get conveyed? They change tiers, they go from premium to basic. How does that get conveyed? Well, you need a path from that billing system where somebody who's managing that account can convey that back to your tenant configuration and have that cascade through your whole architecture. So it's that life cycle there where the tenant changes status that people miss in their architecture. Okay, what are some of the key takeaways here? Well, hopefully it's pretty clear there's not like a one-size-fits-all. I think when you came here you might have expected that, but I'm hoping by looking at this you can see there just isn't a one-size-fits-all approach to this. Silo, pool, which kind of auth model do I have? Which kind of compute model am I using? They all affect isolation and so on. So hopefully instead we looked at just a good set of patterns there. You have to think about variable consumption. You have to put that into your math. Your multi-tenant calculus has to think about how is my system going to react and change when the profile of my tenants change, or I get a lot more tenants in my system. I think I beat this one to death, but please make metrics part of your equation. I won't say more on that. And then isolation. We talked about isolation, but you have to be fair. I didn't really give you a magic silver bullet to say this is exactly how to do isolation. But it's a problem you have to sort of get your teeth into and go after. And then no matter what you do here, if agility isn't sort of baked into this sort of mindset, and you're not thinking about ops, and you're not thinking about DevOps, you're going to miss the mark here, right? Don't have a great architecture that gets deployed once a year. That will not be a success. Cool. So just a couple highlights. There's a bunch of breakouts going on here. I have some that are going on. There's no way you're going to get these fast enough, and there's some I haven't included here. But I have a serverless talk. I have another deconstructing SaaS talk. We also have a ton of chalk talks by members of my team. So there's chalk talks on migrating and at different levels here, optimization, metrics, so on. And then cool is we have two sessions of the same workshop, which is a hands-on SaaS workshop if you're sort of wanting to get your mind more around the details, you might really like these workshops as well. So that's it. We made it. Really appreciate you being here. And please fill out your surveys. And if you have questions for me, I'll hang out outside there for a little bit if anybody has any questions.